Welcome to this tutorial on Kubernetes selectors. In this video, you'll learn how to query and filter Kubernetes resources using label selectors. This is a fundamental skill that will help you efficiently manage and organize your Kubernetes objects. By the end of this tutorial, you'll understand how to use selectors to target specific groups of resources for operations like scaling, routing traffic, and performing updates. Let's start by understanding what selectors are. A selector is a query expression that filters Kubernetes resources based on their label key-value pairs. Think of selectors as a search tool that helps you find specific objects in your cluster. The purpose of selectors is to enable targeted operations on specific groups of objects without having to manually identify each one. This means you can perform actions on multiple resources at once, as long as they match your selection criteria. Kubernetes supports two types of selectors. First, we have equality-based selectors. These match exact label values using operators like equals, double equals, or not equals. They're straightforward and work great when you need precise matching. Second, we have set-based selectors. These are more flexible and match label values within sets using operators like in, not in, or exists. Set-based selectors give you more powerful filtering options when dealing with multiple possible values. Let's dive deeper into equality-based selectors. There are two main operators you can use. The equals or double equals operator matches exact values, while the not equals operator excludes exact values. An important thing to remember is that when you specify multiple requirements, they're combined with a logical AND operation. This means all conditions must be satisfied for a resource to be selected. For example, if you specify environment equals production and tier equals frontend, both conditions must be true. Here are some practical command line examples. For a single condition, you can use Kubectl get pods with the -l flag followed by environment equals production. This will retrieve all pods where the environment label is set to production. For multiple conditions, you separate them with commas, like environment equals production, comma tier equals frontend. And for exclusion, you can use the not equals operator, such as environment not equals development, which will return all pods except those in the development environment. Now let's explore set-based selectors and their operators. The in operator checks if a value matches any value in the specified set. The not in operator checks if a value matches none of the values in the set. The exists operator simply checks if a key exists, regardless of its value. And finally, the not exists operator checks if a key does not exist at all. These operators give you much more flexibility when filtering resources based on multiple possible values or checking for the presence of labels. Let's look at command line examples for set-based selectors. For the in operator, you use Kubectl get pods -l followed by environment in parentheses containing production comma staging enclosed in single quotes. This selects pods where the environment is either production or staging. For the not in operator, the syntax is similar but filters out the specified values, like tier not in cache comma proxy. And for the exists operator, you simply specify the label key without any operator, such as Kubectl get pods -l release, which selects all pods that have a release label. When working with YAML manifests, you can use the matchLabels field under selector. MatchLabels uses equality-based matching for simple key-value pairs. It's the most straightforward way to define selectors in your YAML files. In this example, the selector has matchlabels with app::nginx and environment::production. This means the selector will match any resource that has both of these exact label values. MatchLabels is commonly used in services, deployments, and ReplicaSets. For more advanced filtering in YAML, you can use matchExpressions. This enables set-based matching with flexible operators. Each expression contains 3 fields: key, operator, and values. The key specifies which label to check. The operator defines the comparison type like in, not in, exists, or does not exist, and values is an array of acceptable values. In this example, the selector matches resources where the environment label is either production or staging. MatchExpressions give you the full power of set-based selectors in your YAML configurations. Let's wrap up by looking at common use cases for selectors. First, service discovery uses selectors to route traffic to pods matching specific labels, ensuring your services connect to the right backends. Second, ReplicaSets use selectors to manage pod replicas based on label criteria, maintaining the desired number of identical pods. Third, deployments use selectors to target specific pods for rolling updates, allowing you to update applications without downtime. And finally, resource queries use selectors to filter and list objects across namespaces, making it easy to find and manage resources in large clusters. Mastering selectors is essential for effective Kubernetes management.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.